I am a polar line, so.
Oh, good.
I'm going to try just going to the moon, see what I can find.
That would be great. Going to the moon would be great. I'll take a shot of the moon too. Actually, why not?
I've never done it with this camera, so we'll see.
Yeah, we'll figure it out on the fly. We got time. All right, hey everybody, welcome to the Virtual Star Party. This is, of course, the final Virtual Star Party number 8, the last one before we go on our 2-month summer hiatus. I know we only got 8 episodes. That's because we started doing them 8 weeks ago. But everything around these parts, we go on hiatus for 2 months. But that said, we will be doing a bunch of tests to try new cameras, new telescopes, new equipment, new astronomers over the course of the entire summer. It just won't be scheduled. It'll be completely ad hoc. There's no rhyme or reason. I make no guarantees. But joining me this week, we've got Stuart.
Hi.
Hold on. There you go. Okay, Stuart, madly setting up his telescope. You should go back to the telescope. That was awesome.
Probably will have to.
Yeah.
Oh, my scope's right there.
Yeah, you're polar aligning right now. You can see now.
I'm polar aligned. I'm now gonna see. There's the scope, and now this is what I'm going to try to hit. Which, see if you can see it. There's the.
I can see that thing.
There's a live view of the moon. Everybody, see it?
Oh, cool.
Yeah, that's awesome. That's perfect. So Stuart Foreman, you're in California, just outside the sort of Oakland area, and you are going to be. You've got the best skies tonight. You've got the best telescope. You've got all our hopes and dreams are riding on you, Stuart. So lovely. I know you've set a great big automated list of objects that you're going to be targeting, and so we'll be rolling through those as quickly as we can. Awesome.
It's got to get dark first, but yeah.
I don't know. You know what? I don't care. The moon will be as whatever you require. Yeah.
All right.
We've got Linda Thomas Fowler. Hey, Linda.
Hey.
And you have moved to the International Space Station, Cupola.
The weather has been so bad here in Northern Virginia. I asked NASA to bring me up to get above it. They didn't tell me I couldn't bring my telescope.
Right. It's either that or the Millennium Falcon.
Yeah. Yeah. And so the point being that your telescope is clouded out tonight.
Unfortunately.
Yeah. Now you have, I hope, been taking some pictures over the last week that maybe you can share some stuff in some downtime.
Yeah, I have the picture of the Leo triplet that I had been working on. I finished mostly because I can't see it anymore.
Yeah.
And I also started working on a Western Veil picture in narrowband. So I've got some intermediate results there.
Okay, cool. And then we got Dave Dickenson. Hey, David.
Hey there. I was hoping to bring my new toy in tonight, but I'm in Virginia and we're cloudy here as well.
Yeah.
So
well, you got a new toy, therefore you're going to have cloudy skies.
Yeah. It was clear last night.
Mm-hmm.
I actually did get it up on the parking garage roof here, and I thought I should use it in case it's not clear the next couple weeks at all.
Yeah.
That might be the only night I get. So I did do as much as I could with it last night.
And so we're going to spend some time and actually talk about that because it's another test telescope that you've gotten. This one is like the main competition to the Stellina. This is this is the EV scope from, who makes this one? Unistellar, but it's same thing. They
kickstarted it a few years ago.
Yeah, but like a highly automated telescope. This is where you put a telescope up, it figures out where it is, it takes pictures, and you get to just enjoy it without all of that difficult polar alignment, which Stuart is currently trying to do.
Oh, I'm polar aligned.
Yeah, good. Yeah, it only took you 15 minutes.
1 minute.
Just imagine people in a big lineup waiting.
I know.
Yeah, we've been there. And we've got Dr. Thad Szabo. Thad, welcome back.
Good evening.
And you also have terrible skies.
Yeah. Friday night I was able to get out to shoot for a while. Clouds rolled in around 1 a.m. and sky's actually been pretty socked in most of the weekend since then. So kind of, usual June gloom here in Southern California. And so that's what we've got going on. But I did get, a hyper detail shot of the moon on Friday night, as well as the Swan Nebula M17. And using some processing tips that Stuart gave me, I think I was able to bring out some nice detail in that. So
that's awesome. Okay, and I've got, you can see the Rasa down in the bottom right-hand corner of the screen right now.
Fraser, you need to enable screen sharing.
Okay.
Sorry.
Let's see. Hold on. Now I'm screen sharing. Okay, hold on.
Okay, good.
No, wait. There. Okay, you can screen share. So
right,
I'll show you what my view is. So this is my view with the Rasa, and you can see we've got these clouds all around. And this is the moon, and you can see this halo around the moon. So I've got a rough night. It's gonna be we're gonna be searching for sucker holes. We're gonna
That's rare for that site.
Yeah. It's a little better to the west, much worse to the east, but you can really see how bad the clouds are. And this was about 15 minutes ago. So really everything's on you, Stuart.
Yeah, you still need to share. You still need to enable screen sharing.
I did. Multiple. Okay, here. There you go. Multiple participants can share at a time. There.
Okay.
Yeah.
Share. Okay, there it goes. All right.
All right. So, but the telescope is there. I'm just focusing it right now, and hopefully, hey, there you go. You got the moon.
Okay, so this is. I have never taken a picture with the moon with this camera. This is 0.01 of a second luminance. I can try a different filter and see if it brings it. Like maybe a hydrogen alpha filter?
I'm going to do the same thing. If you can you do
a
a bit of a lower exposure? Are you still binning it?
No, I'm not binning the moon. I'm going to put it on hydrogen alpha and see what happens.
Yeah.
Yeah, it'll cut out a lot of light, so that.
That's kind of my idea.
Yep.
Hang on. Let's do a.
Are you shooting with a refractor or a reflector?
It's a refractor, yeah.
Okay. Yeah, I don't know if you get any chromatic aberration with that, but that's one advantage you can use with shooting with a filter like that with the moon, is that since you cut it down to one wavelength, you can really sharpen up the pictures, because there are refractors that are built to not have this kind of fringing at the edges where say the red light comes into focus at a different place than the blue light. But if that's an issue that you're working with, putting in a filter like this can make it possible to get still really sharp images, because then you're only letting one wavelength through to the camera.
Right.
Yeah. So, there you go.
There we go.
So this is with a hydrogen alpha filter.
That looks great.
0.01 seconds. And I've never done this before. Cool.
I feel like that's my job, is to get you to do things, to push your gear in places it was never meant to go.
Oh, it's freaking awesome.
Yeah. There you go. So now you're doing planetary.
Yeah.
I think we're just past the point of the Lunar X is already out, but I think it's past the Terminator now. I noticed last night it wasn't out yet. Like now it's out.
So can you enhance and zoom?
Yeah, let me see.
Hard to tell on my phone because I'm looking at a tiny little screen, but I think it's past.
Get rid of me.
Oh, look at this.
Oh, yeah.
It wasn't visible on Friday night, so
yeah. Last night it wasn't out either. But it was first quarter last night, so.
Oh, that's terrific! And then get rid of those little histogram-y things.
Oh yeah, hang on. Sorry. There. I can't get rid of the line because it's a frame in focus.
Right.
And it's not completely focused because I haven't actually focused the camera yet, but it was focused from a couple nights ago, so it's not bad.
That's cool.
I can actually see when the Lunar X comes out online when I just follow people on Twitter and start looking at their moon photos and picking it out. I'm like, oh, it's visible now because everybody's moon photos.
So what is the Lunar X, David?
It's the confluence of I believe it's 3 craters where the rims kind of match up, where when the sun hits the top of it just right, but the base of them are still in shadow. If you look along the Terminator at just the right time, right around first quarter, it looks like there's an X hanging kind of out in the dark side of the moon, just past the Terminator. I forget the name of the craters. I'd have to look them up. But,
and so why is it only visible from certain times of the
It's right. It's
of
right
the
as
month.
if you were standing on the moon right there, the sun would be coming up. It's kind of like if you ever seen on Earth where the peak of a mountain is in sunlight because of the curve of the Earth, but the base is still in shadow. That edge of those crater rims that just happen to match up right there, they're just catching the first rays of sunlight when the sun comes up. Standing there, you would see the sun come up and the Earth would be straight overhead. The Earth would be the reverse phase too.
So I just took a picture of the moon as well, and you can see the problem that I'm having is no focus. So I'm trying to focus the telescope still.
I'm almost ready to start my run here.
That's
but it's
awesome, Nancy. You made a primer on binning as a link in Nightbot. That's really cool. Linda, you've got some pictures that you took this week. So while Stuart is still trying to get set up, did you want to share some pictures? You're muted, by the way.
I do, but Zoom is being unhappy with me for a moment. I might have to quit and rejoin.
We've got, what I'm saying is we've got lots of time for questions tonight.
So
Yeah,
I also, sorry, I was just going through my photos. So I have an image of the moon from 6.9 days past new, and that's when the lunar X shows up. So if you want me to share out
Yeah.
this image of the moon here. Okay, give me a second. Okay, so this is, yes, I guess this was from April 12 of last year. And this was actually just holding my cell phone up to my 10-inch Dobsonian. So I have an Instagram account, lunar_Thad, where that's basically what I do. I've had this scope since I was 15 years old, over 3 decades ago. And so it just wasn't getting used much. So now if I see that the moon's out, I pull it out of the garage, hold the cell phone up to the eyepiece and get a picture. So that's essentially how this was done here. Let me zoom in on this a little bit. And
I see it. I totally saw it. As soon as you posted up the picture, I could see the lunar X.
So that's the lunar X. And at about the same time, there's a lunar V that shows up more toward the northern part.
Just below it there. I think I do see it.
Yeah. Yeah. So the X definitely stands out a bit more. And let me see if I can get the crater names that would go with that, right? So we've got, let's see, we've got this little chain down here.
I think it's Purbach because sometimes it's called the Purbach Cross. That sounds familiar.
That sounds right. That sounds right.
One of the craters. I wrote about these, but I have to look it up again.
Okay. But that's really cool that only shows up as the Terminator is crossing. And so you can only see the lunar X for what, 2 days maybe?
Not even. It's a few hours.
A few hours.
Yeah.
And so you can calculate the exact time that you're going to see the lunar X, and then boom.
Once the sun gets up a little higher, it hits the base of that area and it just kind of fades into the rest of the terrain.
Johnny J is asking, I had a kid ask why the moon craters are so shallow, and I couldn't answer. Can you? I think lava.
Let's see. So part of what happens whenever you have a big impact like this, and some of these things that we're looking at along the boundary between light and dark here, which are visible in Stuart's view, you're looking at things that are tens or close to 100 miles across. But yeah, they're about maybe a mile deep. So as far as the ratio of the depth to how wide they are, it's pretty big difference. When the crater first forms, when an asteroid first hits the moon, to do something like this. And again, most of what you're looking at here as far as the craters go are probably around 3 billion years old for the really big ones that you're seeing there. So first it blasts something quite deep, and the impact at first can be a few miles deep, but then you vaporize a lot of rock. So there's a lot of rock that will turn to gas in the extreme heat of that impact. The walls will slump inward. So when you have this material that was disturbed in the impact like that, so it starts off narrower and deeper, but then the walls will slump. And so what happens when everything settles down again after the impact, you end up with a crater that is wider and shallower. If you want to play with this, there's a site from Purdue University. So if you Google Impact Earth from purdue.edu, you can send projectiles of various sizes and densities at Earth, and various velocities and angles, and it will tell you what the effects would be, and you can kind of place yourself, okay, I want to watch this from 100 miles away, or I want to watch this from 5 kilometers away.
Yeah.
And it goes through the lists of like seismic effects and how bright the fireball would be if it came in when it comes in, and what the initial shape and depth of the crater is, and followed up with, after it all settles down, this is how wide it'll be. But essentially it's that kind of geologic slump that happens, that makes them end up being a lot shallower and wider when it's all over.
Right. Linda, this is your Leo triplet.
Yeah.
And
Yeah,
I do like the way that you've oriented it.
I'm glad you approve.
Yeah, to get that meh.
Yeah. This a couple of weeks ago, we actually did a live stack of some data from this, and I was hoping to get about 24 hours total, 8 hours each of red, green, and blue, and actually maybe even try some hydrogen alpha if time permitted. But the weather this spring was so bad that I made the mistake of getting all my green, and then by the time it was going behind a tree, as soon as it got dark, I was only able to get about 90 minutes of blue and 70 minutes of green, or the other way around. But I decided to stack it all up and see what I could get, and this was the final result. And I was actually pretty happy with the way that came out.
Yeah, it looks fantastic.
Yeah, the colors and detail in there are really good, and it definitely shows, you have the two spirals at the top, M65 and M66. I'm trying to remember which one. I think M65 is
Hamburger Galaxy is the
and
bottom
the
one?
Hamburger Galaxy NGC 3628.
Yeah, M65 is this one, and 66 is that one.
Okay, so M65 is actually gravitationally disturbed M66. So what you see with the asymmetrical spiral arms on M66, one of the arms is actually, if you think of a spiral galaxy, it's a plane, but one of the arms has gotten kind of bent out of the plane a bit. And you've captured that pretty nicely with that, with the way you've constructed this image. So good work there. You can really see how the one is has a more disturbed structure than the other.
That I have them down like about 45 million light years away. So these are gravitationally bound, I think.
Oh, they are together with each other.
Yeah, it's a group. It's a
I
galaxy.
think all three of these are part of a larger group in Leo.
Wow.
I was just looking in my new book, I have them right about all the same, roughly same distance.
Right.
So they must be.
Yeah, and an even deeper exposure on the Hamburger Galaxy, or the mouth of our meh there at the bottom. There's some good tidal tails of gas that come off of there. They're very faint, so I mean it's something where the processing has to be done to go for much longer and from a really good dark sky site to bring out those tidal tails. But all three of these galaxies are actually gravitationally bound to each other, and they've interacted gravitationally, and that's caused some distortions to the Hamburger Galaxy and to M66.
It's interesting that Charles Messier missed the Hamburger Galaxy, because the other two are about the same brightness.
Yeah.
He only saw two, but not.
This was actually slightly dimmer in the image. I had to bring it up a little bit to get it to about the same as those, but it's not a huge difference. It is surprising he missed it.
Yeah.
There's a bunch of surprise ones that he missed.
Yeah.
Well, he was using, I think, a 3-inch refractor. I think it was, and of course it had chromatic aberration, and it wasn't the greatest instrument. But
there's a thing to think about when you're choosing deep sky objects, which is the surface brightness. So you might have two objects that have a very similar magnitude. So for example, you could have a globular cluster like M13, and you could have a spiral galaxy like M33. The thing is, though, because M33 is spread out over so much more of the sky, that it's much harder to pick up because it's the same amount of light, but when you've smeared it out over more of the sky, it just doesn't stand out as much. So even though it's a bright enough target to pick up naked eye under exceptional conditions, it's still pretty tough just because of how the light is spread out. And I think that might be some of what's going on with the triplet here, is that, M65 and M66 up at the top, the light is confined to a smaller area of the sky, which is going to make them stand out more. Whereas you can see that NG3628 at the bottom, it's larger on the sky, even though it's just a little bit fainter, but that spreading out of the light is going to make it stand out less.
Hey, congratulations, Chris, on setting up a new telescope. Tell us which direction you've gone for in the chat. And through OPT, I'm sure OPT is pleased. There you go. Worth it, Dustin. Thanks for letting us use your telescope.
I was going to say that comets fall prey to that same loss of magnitude due to surface area as well. A lot of times they're actually fainter visually than what they're quoted.
And I guess one to look for, gosh, I'm trying to remember. There've been a bunch of them around. Is it Neowise?
Neowise is in the view of Soho right now.
Yeah, so it's
I'm actually getting ready to write about this week for Universe Today, because it's getting out of the view of, it's off in the direction of the sun right now, but it might be a good binocular comet. We've had a string of good binocular comets.
Yeah. Amandaville's asking, is Stellarium a good application for someone who doesn't have a telescope yet? Sure.
It's free.
Yeah, it's free. Yeah, Stellarium's fine. But Stellarium should be your gateway to actually going outside and learning the night sky. So take a pair of binoculars, or even just take a book, for example, the upcoming Dave's upcoming book will do the trick, or even just a sky wheel that'll show you all the constellations of the night sky, and then just start to learn your constellations. Like this is how we all did this, I think, is that you start with something really easy to find. In the summertime, start with the summer triangle, which is the Vega, Deneb, and here, let me find them, since I can't find them here. The summer triangle, there we go. So the three bright stars, Vega, Altair, and Deneb. Right now, if you go outside and you look up, the three brightest stars in the sky are going to be these three stars, Vega, Deneb, and Altair. And they form this triangle in the sky. And each one is part of a different constellation. So Vega, pretty much the brightest one. Maybe Arcturus is a little brighter than Vega, but you've got this constellation. It looks like a little fish almost. And then Deneb is part of Cygnus, which is the swan. And Altair, I don't know what Altair is. An old computer.
Altair's like the tail of the eagle.
The tail of the eagle. There you go.
Yeah, Aquila the eagle.
Yeah, Aquila the eagle. So there's Aquila the eagle. And then you just go from there. And then you also know where, say, the North Star is, Ursa Major, where the Big Dipper is. And you can follow the end of the Big Dipper to the Little Dipper and to Polaris, which is the North Star. And you can see how Polaris comes back like this. So you're just going to learn these constellations one at a time out there, just looking at the stars. And over the course of the year, you're going to see different stars come up night after night after night. And you will eventually, they will become familiar to you. I read the sky like I'm reading a book, like I'm reading the letters in a sentence. I look up, I realize where I am, and then I'm able to orient myself and be able to see what's up and what's what's up in the night sky, and then you can take your telescope and you use those as your guideposts to be able to then find individual specific objects. Like there's a couple of classic examples. I'll just show you this here. Like if you have a small pair of binoculars, once you learn to find Hercules, and it's very easy to see. It's got this big parallelogram as a chest. You can see he's got these arms and legs all akimbo all around him. And when you learn to find that chest part, almost halfway in between the chest is the great star cluster in Hercules. And once you learn it, you can never unlearn it. And so you always find it.
I have the Hercules cluster.
Yeah.
So
you have it right now.
Yeah, got it right now.
Okay, great. So there you go. And so that's what that thing looks like when you look with a small pair of binoculars. So you just got to go out, and then you learn different constellations in the wintertime than you learn in the summertime. Actually, you learn different constellations in the spring and in the fall and in the summertime and in the wintertime. And month after month, you just learn your way across the night sky. And I'm sure that's what all of us did. And there's nothing complicated to it. You just have to go outside and look up and just find your way.
This one is easy to see in a small scope because the landmarks are pretty clear. It's like directly in between two stars, and and it's very, very bright.
Yeah, that was the first deep sky object I ever found on my own.
Yeah, it's such a crowd pleaser. I mean, it just.
I like M3 too, but M3 is hard to.
Yeah.
It's in an area that's pretty vacant. It's a tougher one to nail down. It's about the same brightness.
So Amandaville's saying, I might be looking at different stars than you because I live in Thailand. Well, not really.
Not really.
Yeah, if you're in Thailand, you're still in the northern hemisphere like us, so you see the same constellations that we do. You just see them 8 hours before we do.
Well, Thailand's close enough to the equator.
Yeah.
Because if I think, Singapore would be
Singapore
at the very
is
south
right,
end of the
Singapore
peninsula.
is almost right on the equator.
Yeah, so you are going to see what we see down closer to the horizon. You're going to see directly overhead, and you're going to be able to see down into the southern hemisphere constellations as well. You can probably see the Large and Small Magellanic Cloud. You can probably see the Omega Cluster. I'm not sure you could see all the way down to, say, Alpha Centauri, but you can.
Oh yeah, easily from there.
From there, okay, sure.
Yeah.
From Florida, we used to be able to, in late April, we could pick off Omega Centauri and the top of the Southern Cross. So there's some southern objects you can get even from the contiguous U.S.
Yeah, in theory, Omega Centauri gets 5 degrees above the horizon here, but I've never seen it.
Florida, it was pretty easy in the spring, right around late April.
Okay,
is the best time.
And the other thing is, if you're using Stellarium to learn, it will pick up your location from your IP address. So it will adjust the sky to look like how it looks from your location.
Yeah.
So that it'll make that adjustment.
Yeah.
One thing I do want to recommend, aside from using these apps, there's all sorts of little tricks and mnemonics of how to navigate from one one set of stars to another. I just want to mention the book, The Stars, by H.A. Ray.
That's a good one,
yeah. It's just, the way constellations used to be drawn were really confusing for people, and so he kind of redrew them so the figures looked a little bit more like what they were actually supposed to represent on the sky, because he was trying to teach, I forget if it was his niece or nephew, how to define their way around the sky. And so it's way more accessible using those drawings. So if you can find an old copy of that, used copy of it, go for it, because that's going to be a great way to start.
So there's my M13.
Nice.
So I'm able to get it as well right now. And how long was your exposure, Stuart? That's a 30-second
1 minute.
exposure. Yeah, I did a 30-second. Anything beyond that, it just starts to get gross.
Yeah.
On this one.
Like this.
Hey, this is Frank. I'm pointing on M13 too.
Oh, hi, Frank.
Hey.
I'm sorry, I'm late. I was waiting for the sky to get darker to be able to do the set up the telescope. I don't know how you want. If I can show you my screen.
You should be able to share your screen share into the.
Yeah, he said it cannot start screen share while the other participants is sharing.
Let me undo it.
You should multiple can share simultaneously, so you just have to tell me when you're sharing, and I'll
fix it.
Yeah, and I'll be able to switch over to you.
No, still not.
So we've got a copy of one of your telescopes. So Dave Dickenson has the telescope in the
In
background.
the background here. Yeah. I had it out last night. It's pretty incredible, actually. It's going to spoil me for actually looking through an eyepiece now, I think, these types of telescopes. So,
Dave, where should I go now?
Have we ever done the wild duck cluster, M11?
No, I'll do that.
It's kind of an overlooked, it's an easy one in Scutum.
It's good to do that right now, early on.
I have M56. It's another itty bitty little glob.
Oh, good.
Oh yeah, I was looking at that last night. I think that's in Hercules, I think.
Yeah, it's close.
Or Lyra, maybe?
Or Lyra, yeah.
Yeah, but it's that part of the sky.
I'm sort of pointed in that area of the sky.
So which was that again, Stuart?
This is M56.
M56, okay. So
Lyra and Hercules, you're not far off from the Hubble Deep Field area.
So I mentioned the summer triangle, right? Vega, Deneb, and Altair, and this is almost dead center in the middle of this triangle. This object M56. And it's just another globular cluster.
And any of these objects, they're old. I mean, if you can look at the population of stars in any one of these star clusters. So anytime you have a region of gas and dust, if you can get some of that dust to be cold, it can collapse under its own gravity and start to form stars. But it's never going to form just one star. So it'll form a cluster of stars. You'll get what's called a stellar nursery. And the more massive stars will evolve faster. So they will become giant stars and either blow up as supernovae or form a white dwarf and have their outer layers of the star drift off into space. So then you're just left with older, cooler stars. So when we look at these globular clusters, there are no young stars in them. The stars in them all have ages of like 11 billion, 12 billion years old. So whenever you're looking at something like this, you're looking at something that's left over from the formation of the Milky Way galaxy. Globular clusters are all old star populations like that.
I will show you my view of the sky right now. And you can see it's gotten a little better, but still the moon is this big blob in the sky. You can see some of the clouds over to the east. But it's kind of improving, so I think I'm going to be all right. Lappy on Twitch is asking for M57. No problem.
I'm M56 right now.
I'm M57's on my list.
Yeah, okay.
I shot it last night. I don't know if I can share.
I'll move it up the list to next. Ask and you shall receive. It will be after the one I'm acquiring now.
Okay, great.
Pretty sure I could share one from the EV scope from last night.
That'd be great.
I think. I can't share right now though.
Well, I've set it so you multiple participants. Okay, advanced sharing. Who can
Let me stop
share?
sharing here.
Yeah, it says anyone.
I stopped sharing. See if that helps.
Yeah.
Okay, I think.
So I did it.
Okay, it's working for me now. Good.
Yeah, it's working here too.
Was I freezing everybody up?
Oh, it's working. Can you see on my screen?
Yeah.
Yeah, we sure can.
So this probably is like not even 20 seconds of exposure.
And that's a shot of M56 as well?
Yep.
Oh, that's great.
So let's see. You want to go back to M56 or you want to try M57 first?
I'm doing M57 right now. Hang on.
Okay, so that's the way you go to M56. You basically enter it. While it's pointing to it, you will basically be able to read information about M56. So distance, number of stars, basic information about the body itself.
And I got M92 up when you want to flip over to me.
Okay, let's see.
It's another block.
Yeah. There you go. There's Stuart. All right, I got your wild duck cluster, Dave.
Oh, cool.
Yeah. Yeah, that's better.
Yeah, this is one of the better open clusters. Kind of get a bad rap as not that interesting, but this one I think is, especially in binoculars, it looks kind of cool.
Yeah,
I think they're super pretty.
It's a tough one. But I mean, that looks great, Stuart. The M92. So here's the wild duck cluster, and so very different. Like the globular clusters are these huge clusters with hundreds of thousands, even millions of stars, and they are pretty far away from us, high up above the galactic plane. Well, this is the kind of cluster that the sun formed inside of billions of years ago. And so how old, Thad, is one of these open clusters when we see them like this?
It depends. If you are looking where you still have a nebula around it, then you're talking about stars that are only a few million years old. This one, since you can't see the gas and dust around it anymore, it has to have been old enough to have driven that off. So you can kind of the same thing we talked about with the globular clusters is map out the temperatures and luminosities of the stars, and then see from that you can get the ages of the stars that haven't become red giants yet. So for something like the wild duck here for M11, I want to say maybe about 200 million.
Okay.
300 million years old. So you won't see any of the really big giant stars in anymore, but there's still some pretty good bright stars in there. But yeah, the best way to do it is plot on what's called a Hertzsprung-Russell diagram.
And so you can see the oldest star in the group, and that tells you how long ago the cluster was formed.
Well, you can see what are the biggest stars, the most luminous stars that haven't become giants yet, because the more massive a star is, the faster it becomes a giant star. So there's what's called a turnoff point, and so you look for, well, what are the biggest stars before you hit the turnoff point, and then that gives you the age.
Right.
Yep.
According to Sky Safari, it's about 250 million years old.
So I'm going to go back to Frank's view here. So Frank, what are you pointing at right now?
M57.
Yeah.
That's what I'm getting right now too.
Yeah, I just dropped the enhanced vision because the sky is still clear, so it's still bright. So
I like the manual toggle setting on that. I was using this, putting it through its paces last night, and that's it's kind of fun. You can, for the live view, you can just slew it around manually.
Yeah, and I can also move in landscape. I don't know if you have tried that. It's much nicer in this case.
Oh, nice.
Especially for this kind of videos.
And you can zoom in. I just happened to notice touching the screen that you can do the pinch and zoom while you're viewing this through your phone. Yeah, no, it's kind of a neat little toy.
So A-Mitty asked for M109, so I'm taking a picture of that right now.
Okay.
Is that on your list, Stuart?
No.
Good. Well, there you go then. Also known as the vacuum cleaner galaxy.
Vacuum cleaner.
It's interesting. Stellarium gives a lot of exotic names to objects. It's like I've never heard of.
Yeah.
These are all informal, not IAU.
Yeah.
Names, but it's just.
I have my M57 up.
Oh, sure. Okay. Did Messier know of vacuum cleaners when he named his objects?
It's kind of a recent invention.
Yeah. Again, the joke that I always make is the Pac-Man Nebula. Like, how long have we been seeing this object? Is it only? But I think part of it is like there was a whole wave of these hydrogen alpha filters that were finding all of these certain kinds of nebulae, and so that's why they all got fairly modern names.
Yeah, they were too faint for visual observers.
Yeah, but they were able to be seen by CCDs. And so you get stuff that's more recent.
Frank, I also like how the EV scope does star spikes. I noticed I was checking the mirror alignment and I aimed at Vega, and I thought I'll just do a shot of Vega. And actually, that was one of the prettiest things I thought it shot the whole night. It does with the spider veins. It does the automatic star spike kind of pattern. Looks really nice.
So what is the actual telescope in the EV scope?
It's a 5-inch reflector. It looks like a 5-inch reflector anyway.
Yeah, 4.5. Yeah.
Yeah. Because I noticed it's the same size as my little Orion scope. So it's a Newtonian. But it took me a while when I was looking down the tube. I'm like, where is the camera in this thing? The camera is in the secondary. It took me a while looking back at it till I could see the camera chip. So it's kind of like a fast star setup where you've got the reflecting mirror and the secondary is up where the camera is. So
right, like the Rasa.
Yeah. But there's no eyepiece. What I thought the most interesting thing is it's got a manual focus, but the focus knob is on the back of the tube. So when you're aiming, you have a mask that you put on the front. It's actually really easy to use.
Yeah.
You aim at some bright stars, and when you get the crosshair alignment on the stars, then your focus, you've got to get a fine focus manually is really easy. But
Ishmael asked for the sombrero, and it's 30 degrees up, so I can do it, but I got a bad shot of M109, so I can take another crack at that first before I shift over and go. I'll go after the sombrero.
I can't get sombrero. It's
no?
always
Behind the house.
Yeah, it's well below the trees, but yeah.
Yeah. Thad, a question for you. Visto 2D asks, in globular clusters, would alien observers see many close neighbor stars? How close packed are they?
Yeah, I saw that question. I'm actually plugging some stuff through a calculator right now.
I've heard it's like 1 light year on average, while normally in the Milky Way it's more like 4.
Yeah, I remember this discussion going around.
So
how per square light month or light year, how many stars?
Right. So if you're looking at the typical size of a globular cluster and the spacing between the stars, you typically have about a light year to 2 light years in between stars in a globular cluster. Now that's on average, so that means you're going to have some that are closer, some that are farther away than that. The interesting thing though is because these are older star populations, the stars are going to be fairly low luminosity, so the sky overall. It might be the kind of thing, if you had humans looking, you would still need a telescope to see all of that extra richness. A long exposure would reveal a pretty incredible sky around you. But if you think about the closest fainter stars to us, like Proxima Centauri, which is the closest star after the sun, at only 4.2 light years away. And so we have, somebody mentioned they were from Thailand. They would be able to see Proxima Centauri with binoculars or a telescope. It's only like magnitude 11, so it's about 100 times too faint to pick up with the naked eye. So that's the thing, right? Even though there would be more stars that are a lot more nearby, if you were trying to see them with equipment like the human eyeball, you wouldn't be able to see most of them. Now there would be more giants nearby, so you would get an overall pattern of bright giants that stand out more. So you would have more bright stars in the sky because of that. But even though there are going to be so many more stars nearby, there are going to be all of these small, faint red stars that human vision wouldn't be able to pick up. So really interesting question. And
yeah, it's interesting.
I suppose their globulars are pretty metal poor, so there's probably not a lot of worlds that aliens probably wouldn't evolve there, I don't think.
Yeah, probably not, because again, with as old as they are, and that metal poor quality means that all the stars and the material is going to be mostly hydrogen and helium, and if we're talking about life like we're used to, you need the carbon, oxygen, nitrogen, you need phosphorus, you need iron, so you have to have something that's been enriched with a lot of supernova explosions to be able to have the elements that you need to form life as we know it. So.
Fraser, I got Comet Pan-STARRS here.
Oh, fantastic.
Oh, T2 Pan-STARRS. Yeah, it's been a pretty good performer this spring. It's in Ursa Major, I think, right now still.
Can you see it?
It's well placed. So.
Yes. Is that it in your picture there?
Yeah, this guy here.
I think it's
Right
like
there.
10th magnitude right now.
Yeah, it's just a little blob.
Yeah.
But it's a comet.
Yeah.
It was better earlier, but it's still doing decent. We said we got a good string of binocular comets.
Yeah,
this
we
spring.
got a couple of shots of it over the last couple of star parties. So
Yeah, it's been hanging kind of through Ursa Major, so it's been a good northern placed comet, which is rare.
Tropical Tom asks, how does the EV scope manage humidity and condensation issues? Will high humidity or cold temperatures decrease the performance?
Well, you can adjust the focus. I know that. I mean, as far as through the night. Of course, I didn't have a lot from using it last night. I didn't have a lot of humidity here. There's no built-in dew heater or anything like that. No.
That's correct. We tested it at minus 15, minus 17, even in Finland. So it does go all the way down to this temperature. For the humidity, we don't have a system for that. But the detector warm up slightly, so that's allow us to use it to avoid condensation on the window of the detector at least.
So here's my 109 as requested. It's a little. This is my better picture. Little blobby.
But you can see it's a barred spiral.
Mm-hmm.
Right. So, one of the things that was found once we started doing larger surveys of galaxies is that you see how the center isn't. I mean, there's still a bright center to it, but there's kind of like this extended line out to a little bit to the upper left and the lower right, just kind of slightly diagonal to straight across there. And it turns out that about 2/3 of spiral galaxies have that bar structure. When we first started doing these kind of explorations, they thought that was an unusual feature, but now as we've got a better sample of galaxies, we know it's actually quite common. And it seems that small interactions with nearby dwarf galaxies will cause a bar to develop. So the Milky Way has a bar. Andromeda, which is the closest galaxy to us, does not. But it looks like there are more barred spiral galaxies than just regular spiral galaxies. So, or non-barred. I guess it doesn't make sense to call them regular because
barred are regular.
They're actually, the barred ones are the more common type. So.
Yeah.
The idea that the
grand design.
Yeah, grand design. There we go. Thank you, Linda. Yeah. Yep.
The idea, Thad, that we're in a barred spiral, that's pretty new too, isn't it? Like, I think when I was a kid, I remember we were just a spiral galaxy is what they thought in the 70s anyway.
Yeah. So I think I forget if it's come about with more radio mapping of the Milky Way. I would have to look into how they've determined that. But it's really hard to figure out the shape of the thing that you're in, especially when your view is limited by dust and other material. So, the fact that we were able to figure out so much of the galaxy that we're inside of, because we will not ever be able to get a view from the outside, unless some alien civilization decides from extragalactic alien civilization visits us and says, hey, this is the map that we found you with.
Maybe somebody from the large Magellanic Clouds could beam us a picture.
Right.
So
like
David,
Elihu
Hernandez is saying that bright light looks like a supernova. So is that is this where you check?
M109?
Yeah. No, this is M109.
I've M81, M82 when you're ready.
Speaking of supernova, there'll be all kinds of them in there. Yeah.
That's perpetual ignominy with that.
Yeah. Were you there that night, Dad?
No.
I don't think so. I was there. I was doing the moon at that time.
Yeah.
I missed.
I have an alibi.
I'll be honest though, I wouldn't have caught it. I mean, there's always a star field around these galaxies, and so trying to pick up what's nearby and what's kind of typical for that star field.
Is just to find a picture on Wikipedia and compare it, kind of.
Yeah.
The problem is that we had just said this is a galaxy that's really rich with supernova, and we were staring
it doesn't
right
have
at
one
it.
right now.
That wasn't me. Was that Richard?
Yeah.
Richard Drum or who? I think.
No, it was David Dunn.
Okay.
Yeah.
He was doing the narration. I was observing the moon that night.
I still doubt I would
So-
have picked it up. At this
So
point, it's like
talking-
always check. But
It still makes for a
talking
great story.
talking about the supernovae, I'm pointing on M85, and
Yeah, we were talking
supernova
about
is
that
very
earlier.
bright now.
And there's a supernova in
you talk about
M85.
this?
Yes.
So I tried the sombrero and it's too low. I got just a picture of the side of the observatory. So that's not going to work.
yeah, M109, that's just a star that's in the field. So I
Okay,
just
you
looked at a
checked it.
picture of it in Stellarium. So
Thanks. Yeah, because I'm on my phone, so I can't really check anything else.
Yeah, I will definitely go after NGC 457. Lappy 075 is asking for that.
Oh,
in the chat.
that's a great one. I love that one.
Yeah.
the owl
Stuart's
cluster.
got M81 and 82. I've got an image of that I finished back in the winter that shows what happens when you get a bunch of hours on it.
Did you get any of the Flux Nebula?
No, I can't get that from here
Yeah.
in Bortle 7, but the H alpha filter did bring out the starburst
Oh, it's-
region in M82 pretty well.
Too low for me. Yeah, this isn't going to work.
Frank,
It's
one thing I'll say about the EV scope is I really like how I could go after objects that I'm in downtown Norfolk, which is we're like Portal 9 or whatever.
Mm.
About is like our limiting magnitude is third magnitude naked eye here. But I could go after things that I ordinarily wouldn't bother to go after, deep sky objects, down in the 10th, 12th magnitude range.
So Lappy 75, you can see the telescope. The ROS is pointed at NGC 457 right now, and it is not a good look.
Yeah, down in Cassiopeia is going to be tough.
Yeah.
That's still pretty low to the horizon. There's lots of good clusters to try and track down in Cygnus. Those would be higher up.
Fraser, I have the double, but I don't get the double. I can't resolve the two.
Yeah, I wasn't able to last week either.
Yeah, so you take a look at it. You just see a double star there. But it's a cool double star.
All right, I'm
There's
going to
a
go after the
decent
Iris
globular-
Nebula.
That's a good one. There's a decent globular in Sagittarius that should be M71 is usually pretty. I know that's near the Dumbbell, but that's in Vulpecula. Dumbbell's a good planetary too.
Mm-hmm.
I don't know if that's high enough for me either. Well, it should be 35 degrees. Should be okay.
M71, yeah, it's right along
No,
the
the
galactic plane,
Iris
so-
Nebula.
Oh, Iris Nebula.
I'm getting 35 degrees, so
Yeah, those are all good later night or later summer targets. There's what else? I mean, right around Sadr, there's a whole bunch of good stuff. Next to Deneb, you've got the Pelican and North American Nebula.
It's
there's
just
the
rough with
Tulip.
the moon right now and a slight
yeah.
haze. It's gonna just
Yeah,
blow it
yeah,
out.
That's true.
Well,
That's true.
We'll just pass first quarter, so.
Yeah. So I'm gonna take like a 3-minute
I have
shot of the Iris.
Crescent coming up on my list in a couple of.
Yeah, good luck with that one. It's tough with the with the moon in the sky. Like it really knocks away. But I guess you've got a hydrogen alpha filter on it, right?
Yep, I'm gonna do it in HA.
Yeah.
Well, the moon is right near the bowl of Virgo right now too, where all the galaxies are.
So you asked for NGC 6835 Ren C, but that's too low as well. It is 15 degrees above the horizon. So again, not a thing that we can see yet. How high is the Eagle Nebula right now? Oh, could I just get the Eagle maybe?
Yeah,
M16.
Eagle should be.
Yeah,
It's in Serpens, I
30
think. Yeah, so-
degrees.
About
I'll bet you I
30,
could just get it. I'm going to
Yeah.
try for the Eagle Nebula. That'll be
It's right along
great.
the plane of the
I got the
galaxy
Wild
there,
Duck,
too,
so it's the same height.
Yeah, it's not actually not far away. It's like the
Yeah.
other side of Scutum, the
That'd be
shield, I
great.
think is the constellation.
Yeah, all right. I'm going to go after, and then we'll see. I'll keep going down to Sagittarius until I hit the side of the observatory. So maybe I can get the Omega. Yeah,
It's
that'd be
all
great.
in this part of Scutum through. This was the toughest map to do in this book because it's so cluttered with objects to try to make it like
Understandable.
actually
Yeah.
like readable. Like I edited like those areas around the core of the galaxy were very tough to kind of get down to just like where they kind of made sense.
Well, I'll show people here. So this is the sky, and this is the constellation of Sagittarius down here, and it looks like that teapot. Again, one of those constellations that you can learn.
Between Sagittarius, Scorpius, and Virgo, there's like probably a third of the Messier objects are just in those areas.
And so I took that picture of the Wild Duck cluster, which is right here in Scutum, and the Eagle Nebula, as you can see, is at the same height, the same line, about 30 degrees above the horizon for me. So I should be able to get it. And then if I can get the Eagle, that's the Pillars of Creation. And then I can go after the Omega Nebula. If I get
kind
the
of
Omega,
in M16.
Now I'll just keep seeing how far down I can go through Sagittarius, because this is the last night before Hiatus, and it would be a shame not to try to bring in some of those summer Sagittarius constellations if we can. Linda.
Someone asked M71. I have it, but I cannot share my screen again. Sorry.
Oh, and Sagittarius, yeah.
So try.
It's
a nice little globular.
Yeah.
Yeah, it's first time I've observed this one. I think I've never seen it before.
You should be able to share now.
Okay. Yep.
Not too far away is the Dumbbell Nebula M27. Usually that's where
on my list.
Sometimes sweeping around with binoculars when you're looking for M27, people are like, "Oh, there's a little globular there," and that's M71. It's not too far away.
Here it is.
Oh yeah.
Sorry.
All right, here we go. I'm going to go after I'm probably going to have to turn off the light on the observatory.
Frank, how are you sharing that in Zoom? I'd like to know so I could do that.
So I'm on my phone right now.
Okay.
So that's why I can see your picture. If I share my screen, I have to stop sharing and go to Zoom to see your picture. So I should take my second phone out, but it's even more complicated.
But you must have an overall Wi-Fi, because usually when I'm Wi-Fiing to the telescope, it shuts off my phone's mobile data connection.
Yeah, it depends of some phones. Some Android would do that, but any iPhone will not.
Oh, I have an Android. That's probably why.
Fraser, I got M101 when you're ready.
Oh, sure. Okay. There we go. Oh, nice.
And this is 2 minutes into.
Okay, so you can see we're starting to be able to look down the barrel of the telescope. So I do have to shift away. I have to turn off this the light on the telescope, or else it will be the worst picture ever. So I'll do that now. And I will take a picture.
Nice 101. What telescope are you using for this one?
Me? Are you talking to me?
Yeah, Stuart.
The 101 one. I don't know. Sorry.
I have a telescope engineering company 140, so Tech 140 F7.
Where are you located right now?
San Francisco Bay Area in the East Bay.
Oh, okay.
How about you?
I escaped the fog of San Francisco to come to Placerville because
okay.
I have a lot of demos this weekend, so I decided to not
so
test.
You're not far from me. I was in San Francisco today. We went to Ocean Beach. So.
Okay.
All right. So I'm gonna do a short exposure of the Eagle Nebula, see if I can get it, and then I'll do a longer one, something a little better.
Yeah, I live in Pleasant Hill, if you know where that is. Okay. I'm quite impressed, Frank, that you were able to get this share from your phone into the Star Party. We didn't test this out at all, so I was just assuming this would be a disaster, but
my
actually
best
worked.
thought last night to put it in was have one phone aimed at the other phone and kind of show like one doing the broadcast and one connected to the scope.
Oh, I got the shot of the night. All right, I'm gonna do a longer one too, just to see. Oh, that's amazing. All right, just gotta wait for it to download. Oh, right, here's my Iris Nebula. Oh, a little out of focus. Oh, I need to refocus, I think. Okay. or the wind. It's pretty, like I said, it's pretty windy. So oh, that's cool.
I don't know if this is actually sharing. This is just Vega actually through the unistellar scope. I was just aligning the mirrors on it, and then I was like, let's do a stack of images, and actually I thought that looked pretty cool.
So here is the iris, and we did this last week, but it's really cool to see this bright star nestled inside this cloud of gas. Such a cool object. And this is where the color tells, this is where a color camera really plays in your favor. This was
I have one. I just need to configure it.
That's cool. There. Doesn't that, like, the stars are gone all the way around it. And so it really is just this is the nebula all around. And then inside you can see where the star is. I love this picture. Eric XD is asking, any recommendations on what to look for in my 10 by 50 binoculars? I got to see the cluster in Hercules, but that's about it so far. Dave, what do you think?
Just right along that plane of the galaxy, if you start sweeping like we were looking at M11, the Dumbbell Nebula should be a good planetary up in Vulpecula to aim at too. And there's just a litter of open clusters and things right along when you get that plane of the galaxy that's coming up right now.
Yeah,
I notice we're getting Jupiter and Saturn too. I noticed they're coming up in the east. Actually, they're heading toward opposition in a few weeks, so we're going to be gaining those back as well.
Yeah, part of the magic of a pair of binoculars like that is to just look around.
Yeah.
And then you'll see things. You'll be like, what's that weird little blurry bit? And then you check some sky chart and it'll tell you what it was.
I have a whirlpool.
Oh, good. All right. I'll move my... And then I've got an Eagle Nebula. And I've got
the one thing that can be useful with binoculars, I know, if you don't have a tripod, I'll often just find like a tall table or back of a chair or like the roof of a car, hopefully your own, and just kind of set them up on there to help hold them steady, and then you can get a better chance of really kind of taking in some detail. So I know a tripod can be kind of expensive, but if you just want to improvise and just find some kind of tall, steady object, I don't know, maybe a person, even like, hey, can I rest the binoculars on your shoulder? Just sit still, hold really still, and
don't
then
move, don't breathe.
Yeah, don't move, don't breathe. And then use
if you ever try a pair of image stabilized binoculars, they will spoil you for every other.
You'll never go back.
Yeah, you'll never go back.
I have a pair, and actually they're expensive, but they were worth every penny. It's I use them more than any telescope actually.
I'll have to see if I don't know if the department has any.
Yeah, they need it.
Yeah.
I'm a little out of focus, so I'm doing a refocus now, but here is my Eagle.
Oh, you have some color in there.
Yeah. And so you can see the pillars of creation there.
Yeah, the pillars are embedded in the emission nebula, actually. So
yeah. So that's the pillars of creation right there.
The iconic Hubble image is actually just a very tiny core piece of it.
Yeah. Yeah, it's zoomed into this little piece here.
Yeah.
But this is, as you see, I'm a little out of focus.
So now the questions. What do you see the Eagle? So we have arguments various time, people arguing how they see an eagle in this, and I think nobody agree. So it'll be very interesting one day to have a meeting where we all have a discussion and draw the eagle on the Eagle Nebula.
We all have to draw the eagle.
Because it's very weird.
Oh. Yeah, I had to have somebody do that with one of my images of the Wizard Nebula up in Cepheus. That I was like, okay, I have no idea how anybody sees a wizard in this. And then somebody, downloaded the picture and drew an outline. It's like, oh, all right, there's the pointy hat, and it's okay. That looks like his cape. Okay, I kind of get it now.
Yeah.
But yeah, maybe an eagle diving, and its head is where the cluster of the stars is there. But Yeah, that's a stretch. That's a stretch.
Is this the wing here?
Yeah, that's kind of.
Yeah.
If I was going to try to picture it, that's what I would think I would go with. But this is open for anybody's discussion. So
yeah.
No
Yeah, I
consensus.
don't know where
on this.
initially got that Eagle Nebula. Again, these are all informal names, but
Sam is
Ooh.
asking, is it possible to see any of these objects with the full moon next week? I'll be out in the wild. Sure. It just sucks.
of course the moon's gonna be in that area toward Sagittarius, actually.
Yeah.
So
I have the crescent. This
That's
was by
a great
request.
crescent.
This is by request
cool.
of a guy in my
Yeah.
club, Drew. So this is for you, Drew. Crescent and hydrogen alpha, 2 minutes, bin 2x2.
That's terrific.
Very nice.
Yeah, good work. Really subtle features on that. You got a really nice, sharp focus on that.
Mhm.
Can you make it bigger, please?
Yeah. Sure.
And then
Yeah, hang
out
wow.
your
on.
window.
Yeah, give me a minute. Yeah.
Yeah, the thing
No.
to think about looking at what we're seeing here, there's that fairly bright star that's just off center. The material that you're seeing
that?
around that used to be part of that star. So that star in the center is what's known as a Wolf-Rayet star. This is a very massive star, and it's burned through all of the hydrogen in its core. And the intensity from the star is such that it drove off the outer layer already. So the hydrogen, that shell, the crescent that you're seeing around it, used to be the outer layer of that star. So what's exposed now is the helium layer underneath there. And that star is within a few thousand years of blowing up as a supernova. I mean, we talk about Betelgeuse and Antares. Those could be 100,000 years off before they blow up. The one at the center of this crescent nebula here, this is, you've got about 100 times better chance of this going off in our lifetimes than either of those two.
And how spectacular would it be compared to one of those?
Let's see. Probably about as I would imagine about as bright as Venus, if not brighter. Should be. I mean, yeah, it'll easily be the brightest thing in the sky after the sun and the moon. I don't know if it'll be one of these that reaches the point where it'll be visible during the daytime, but you won't miss it. It'll look like, okay, well, there's Cygnus the Swan, and what the heck is that thing up there in it?
Yeah.
So, and there's a bunch of stars right around the center of the Northern Cross of Cygnus the Swan there that are better candidates for upcoming supernovae than either Antares or Betelgeuse. So a lot of these either Wolf-Rayet stars or massive stars that are much farther along in their evolution, that we know that they're converting carbon to heavier elements as opposed to like helium to carbon. So there's a lot, the part of the sky is going to change dramatically over the next couple of millennia.
Tom Garcia is asking, what image stabilizing binoculars are recommended? The Canons, right?
I have Canons.
Yeah, the Canon IS binoculars. They come in two sizes. I think they have like a 10 by 50 and
it's a 7 by 50.
A 7 by 50.
It's awesome. It is awesome.
Yeah, the 7 by 50 is
also
great.
Really expensive.
And they're like $700.
I have the 15 by 45s.
And then the 15 by 45s, I think, are like $1,200.
They were, $1,200.
Yeah.
And I got these 20 years ago. It's hard to imagine. I got them in '98.
So, and they are just
amazing.
They're just ridiculous.
Yeah.
It is.
They're really simple. There's just one button on them. They run on AA batteries, and they just you just hold the button down while you're looking, and it just stabilizes the image. It's kind of the same technology they have in video cameras for image stabilization.
Yeah,
but
they're a little heavy, but it's like it's worth it.
Yeah, yeah. There's
traveling. They're great too, because
there's nothing
sometimes
like it.
I can't always carry a telescope, but I can carry binoculars, like if I'm backpack traveling or something.
Yeah.
So speaking of stars blowing up, Fraser, after the star party last week, I was working on the Western Veil and Narrowband.
Oh, great.
And I can show a little intermediate image from there.
Sure. And Frank, Tom is asking, can I use an EV scope for lunar, planetary, terrestrial stuff? So is it good for planets and the moon?
For the moon, yeah.
Oh, good.
Yeah, for the moon, definitely. Sorry. The field of view is almost as big as the moon.
Yeah.
For planets, you keep in mind that we have a large field of view, so planets will be small. But you can see the rings of Saturn. You can see the Ben and Bells on Jupiter, and good seeing. You can see the moons of the Galilean moon.
Oh, great.
Titan, Enceladus, Saturn. I mean, there is still some fun to do with planets, yeah.
Again, Frank, you're saying, I think what's really amazing is that you can bring in deep sky stuff in areas that ordinarily I wouldn't even go after.
Yeah.
You know, from urban areas, you can do a lot of the brighter, messier objects and deep sky objects that I wouldn't even bother to hunt for down here. Or with for those who live in San Francisco, when it's clear, sometimes I take it on the backpack and I walk in the city and I set it up and I show M27, M57 to people in the summer. It's kind of fun. It's super fast to set it up, so people love to see. I'd like
this
to
kind
get
of stuff,
this out to some star parties because I've done urban star parties. Sometimes you're just looking at Jupiter and the moon, and that's the only two things you can see.
Mm-hmm.
Yeah, yeah. I mean, people always ask me which telescope should I get. I mean, I get that question a million times, and I always talk people away from go-to telescopes because no matter how automated they are, it's still a pain. It's still a lot of messing around to get the telescope pointing at whatever object you're trying to get it pointing at. But there's a new revolution now. I mean, with these new telescopes like the EV scope, that you just put the thing out and it figures out where it is and it just starts taking pictures, and all of that, just that wasted time just goes away. And so I, just like with the image stabilizing binoculars, I wouldn't want to go back. But then the trick is
taken go-to. I've gone through several iterations of go-tos, and it's taken a while to get to that. Really, this literally, you download the app to your phone, you turn it on, you bond it via Wi-Fi, you point it at an area of the sky. Once the GPS is turned on, it recognizes that area of the sky, and then you're just dialing in objects, and it just goes. I'm amazed with these types of scopes how the older go-tos, they would get within a degree, then you had to spiral around and kind of look for the object, and it has kind of really come of age.
Yeah, really impressive.
I have one more on my list I'm getting right now.
Okay. Well, I've got the Swan. Let's see. You know what? I'm going to undo this. Undo what I did. All right, we're going to do this way. Doing the star party.
Can I come take a look?
Sure. I kind of overexposed it, I think. It's a tough one. It's like it's like the Orion Nebula. It's so bright.
Yeah, the core of this is really hard to get. There's something like 50 really massive stars that have formed in this hydrogen region. If other civilizations were looking at the Milky Way galaxy from the outside, the Omega Nebula, the Swan M17 would show up. It would be one of those little pink patches, like when we look at M101 or M51 with hydrogen alpha. This one is brilliant enough to show up, and it is really hard to get the levels right because of that bright core.
Yeah.
So I've got the three wavelength narrow band that I shot of it on Friday night. If you want to share it? So sure, let me go get that. It's on my Flickr account now. Let me share it from there.
Oh, and Linda, there's your supernova remnant. That's beautiful.
An hour of hydrogen alpha on the western veil, and about half an hour of oxygen. And then if you stack those together as an HOO image, you get that.
Wow.
And let me boost that a little bit just to see. It's just amazing how much detail the narrowband filters pull out.
Yeah.
I tried this image.
Paranor is asking, what's the chance of having a radio telescope on a virtual star party? Thad, what do you think? If we got a radio telescope, would that be thrilling or would it be kind of boring?
you'd really need one of the. You need something pretty huge.
Yeah.
And so it'd be
Arecibo.
buying time on a radio telescope unless there was somebody who was willing to donate time for public outreach. I know Nicole Gallucci, who would join us with this in the past, that she provided a radio image of Centaurus A that she had taken when, if I remember correctly, she was in South Africa.
Yeah.
So I mean, you could see the radio lobes on it just fine with that image. The problem is to get really high detailed radio images. You need either an array like the Very Large Array or ALMA in Chile, or you need to do very long baseline interferometry. So you're talking about tying together radio telescopes that could be continents apart to be able to get super high levels of detail. But
do radio observing like during a meteor shower. Like you can get them on FM bands. Sometimes you can pick up meteors.
Yeah,
I have M27 just when you're ready.
Oh, great. Sure.
Okay.
Yeah.
I have it too, by the way.
Oh, great. All right.
And yeah, I have my M17 that I shot Friday night sharing out right now. So.
All right. So there's the dumbbell by Stuart.
And Thad, can you tell us is this the same kind of as the crescent?
The dumbbell.
Yeah.
So the dumbbell. So the crescent is a star that is still undergoing fusion in its core. So it was just a very massive star that a few 100,000 years ago, when it became a red supergiant, shed its outer layers. The dumbbell is from a star more like the sun that is now gone, except for the white dwarf. So the dumbbell is a planetary nebula. So this is from a lower mass star, something less than 8 times the mass of the sun, and has evolved through all of its steps of fusion and is now just an inert, hot white dwarf. And so the outer layers of it are thrown off into space, and that's what we're now seeing as the dumbbell.
All right. I got the Trifid Nebula.
Oh, cool.
Yeah, and what I like about this is how you just get 2 different kinds of nebulae side by side. You've got this redder one and then this bluer nebula.
Yeah, the Trifid's a great example of this. So essentially, when I'll go over this in lecture, I mentioned there's essentially 3 types of gas and dust that you can come across in space. And I'll bring up a picture of the Trifid because you have hydrogen that's being lit up by very hot, massive stars and causing the hydrogen to glow with that characteristic red color. A little bit farther away, the radiation isn't quite as intense. The photons aren't so deep in the ultraviolet. So you get scattering of light off of the dust from that intense light, and that's the blue. And other places the dust is too dense for light to be let through, so those are your dark molecular clouds or dark nebulae. So here you get the emission nebulae in pink, the reflection nebulae in blue, and then these dark molecular clouds where you're having star formation going on as the dark lanes kind of cutting across it there.
Like
so this is the
of nebula.
So this is the Trifid is the object of the week for the Unistellar network. So I don't know if you have mentioned that already, but every week we basically select a target and we ask people who have an EV scope to observe it, to share it, and they learn about it together. That's the point also of this telescope, is not only to get nice pictures, but also to work together to create a community around it.
So I just took a 1-minute shot of the lagoon, and I'm going to try a longer one.
You're talking about doing scientific observations with this, Frank. I noticed there's some asteroid occultations from here in Norfolk over the next few weeks. Assuming it's clear, I may try for them with it to see how it works.
All right. We will send you also some notification when there is some targets interesting in your location. That's why I asked your address last time. Yeah. We did a transit yesterday, a transiting exoplanet, a KOI.
Oh, that's amazing.
I saw that you're going to be able to do that. I saw that in the settings too. Yeah, I haven't tried it, but.
Thad, you should show your lagoon too.
Hold on. Nancy is going to be heading out, but I just want to give a huge shout out to Nancy Graziano for being the executive producer of the Virtual Star Parties, helping us bring them back. She has been working really hard to organize these every week and organize all of the astronomers and get everything going. And so thank you, Nancy, for all of your help. We're probably going to shut this down. I got one more picture. I think, Stuart, you're out of targets. So
I'm out of shots.
yeah. So we're going to wrap this up, but Nancy, thank you for everything. And have a good night's sleep.
Thanks, Nancy.
Thanks, Nancy.
Thanks, Nancy.
Thank you very much. Bye.
All right, so I've got I got one more shot of my longer exposure. So you've got one last shot. Oh, Thad, that's amazing.
Yeah.
Wow.
Yeah, this was from just hydrogen alpha and oxygen from my driveway here under horribly light polluted skies. But those narrowband filters do a great job of helping to clean that up. Yep. So so this is the lagoon again, another one of these star forming regions. You've got some of those really massive stars, but all of these little knots of dark areas in there, there's stars forming in every one of those, right? So every one of these little knots of gas and dust, there's new stars being born in there.
Wow.
Yeah.
And you hit on something too, Thad, that I think it's interesting. There's been a revolution the last few years where people are able to do deep sky imaging from their driveway now, even from suburban areas, with these types of with either these types of scopes or the kind of filters and things that before you usually meant you had to drive out of town an hour or two to do.
Yeah, I'm really grateful for that right now with COVID going on. I can't, I've got health conditions. I can't really risk stopping at like a rest area or whatever and possibly running into where somebody was coughing or something. So the fact that I can still do this from my driveway as opposed to having to drive the 2.5 or 3 hours out to some site like that is a real real blessing.
My observing site during quarantine is the parking garage rooftop is open to the sky. So I just go up there in an elevator on top of the apartment.
So I know Nancy.
Sorry.
Oh, go ahead, Frank.
No, I was just saying it's been very interesting during the lockdown and to see how imaginative people have been to do observations. In our case too, the EV scope has been great for that. Yeah. I mean, people trying on their roof, people gathering in roof, asking access to the roof of their building. There is a lot of stories. People will remember this as a moment where they spend time observing the sky from the cities. That's great. There's a positive side of it.
Yeah, absolutely. All right, so here's my longer exposure. So this is 2 minutes.
That's great.
Yeah. Oh,
that's cool.
Let me see. See if I can. I don't want to. It's a tricky creature here. You gotta get not too much exposure on that eye. No.
Yeah, this is another one where the core gets blown out really easily.
Yeah.
So the Orion Nebula, the Lagoon, and the Omega or Swan or Checkmark or whatever you want to call it, Lobster Nebula, they all have this incredible burst of star formation going on. That
hit your auto, Fraser. See what that does.
It poorly. I don't like it.
Oh, okay.
Yeah. I like to get a little wilder. But I can see even in this picture, you can see those dark blobs that were in Thad's picture as well. I've never noticed them before. That's amazing. Yeah,
these evaporating gas globules or Bach globules. So one of the things we'll talk about in lecture is that stars are born from evaporating gas globules, which is the acronym EGG, right? But they're also sometimes called Bach globules. And if a chicken goes Bach, 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 and lays eggs, right? So I don't know, just a way of kind of remembering and putting all this together for students taking astronomy classes with me. But that's what you're seeing.
Yeah. And so you can see even the focus is a little better now, but the stars are overexposed. So this was too long of an exposure. So I'm not sure how you did your picture. I'm assuming
it was all narrowband. I mean, I did hydrogen alpha and oxygen, and I found when I do because I have the color one-shot camera too, and I've always been a little disappointed with how big the stars are, and so I have to do a lot of tweaking afterwards to try to bring the size of the stars down. I feel like the balance is just so much better using monochrome camera with the filters.
Yeah, right on. Good. Well, what a great night. This was
Great.
this was a lot of fun.
I'm glad I wasn't the only one.
Yeah, no, for sure. And there's Frank's last shot of the dumbbell.
Sweet.
Yeah,
cool.
it's the moon is
Trifid
very
Nebula.
like washing it up.
Yeah, but
it's
you could
still
see
there.
some of the color right along the edges of it. That's
Yeah.
nice.
Actually, Frank, I did think I met you once in front of the Exploratorium when you were doing it.
Yes, exactly. I recognize your voice and I recognize
Yeah.
your face.
So yeah.
Because in star parties we barely see each other. So
Right.
it's
I know,
mostly the
that's the
voice.
thing.
It's like, yeah, is San Francisco, Unis? I was, oh yeah, I remember Frank.
Yeah.
But
Cool.
thank you
Well,
for having me, by the way.
hey, thanks for joining us. It was a
That's
real
great.
treat, and glad we could show people the EV scope in actual function. Now, you guys were generous enough to send one to Dave, and of course, Dave's going to be doing a review for Universe Today, so
Yep.
you can see what that telescope actually looks like behind him, and so we'll be getting that
I
up on
did
the.
get it out. I did get it out last night. I thought just in case that's the only clear night I get in the next few weeks, I'm not going to waste it. So I did get to try it last night.
Yeah, totally. Excellent. All right.
Sweet.
All right. Well, I'm going to. What have I done? Okay. Where's me? Okay. So, everybody, thank you so much for joining us this week for the Star Party. This, of course, is the last one, the regularly scheduled Star Party that we're going to be doing this summer. We come back in September when we come off of our hiatus, and we will get back into a full schedule of them, and we'll be able to start earlier. So probably by September, we'll be able to start 8 o'clock, I think, and then move earlier and earlier over the course of the year, probably getting as early as about 5 o'clock in the summertime.
Yay.
So yeah, I know that'll be good for some of the other people.
And in the September, all the cool Milky Way objects will be sky high, so it'll be great.
Yeah. So, and then of course, but I will be doing a pile of experiments, a lot of tests, a lot of trying to add new capability and functionality to the virtual star parties, doing some collaborations with various astronomers, testing out their gear. So this won't be the last that you're going to see of me, but this will be the last that you will see of me on a schedule. So that it's going to be a lot more random, but hopefully both here and on Twitch. So hopefully you will all be able to join at various times. All right, I'm going to go back to the star party. I'm going to shift everybody to the grid view. Now, how do I get I think because the sharing is on. Yeah, there we go. All right, let's see if I can go the gallery view. There we go. There's everybody. Okay. And then I'm like hiding up in the upper corner. So thank you everybody for watching us this week. Thank you to our moderators. Thanks to the people who are resharing this over on Twitch. Thanks Stuart, Linda, Thad, Dave, Frank, for joining us and bringing either telescopes or knowledge. I really appreciate this. This was a lot of fun. We will throw some of our pictures into the directory for this week, and you can, of course, download the FITS files, mess with them on your own, put them as your screen's background, and we will see all of you in 2 months. Thanks, everybody.
Bye.
All
Thank
right.
you.
Thanks.
Have a good
Bye-bye.
night.
Bye.
Bye.